I am Hossein Sanai. I'd like to introduce you today to the Focus XC, one of the most flexible instruments for peptide synthesis in the market. Not only you can make peptide, but also you can make the DNA, PNA, or any type of chemistry with this system because of the flexibility of the software and hardware. Focus XC is a continuation of Model 90. Model 90 was developed in 1988 for the university to use by a student to teach them how to make a peptide, and it would be simple to use. But later on, it was used not only by the university, but also by a lot of custom houses making the cGMP peptide and API peptides actually. And some company has as many as 20 and 30 of these because it's simple to use, it's reliable, and it's also can be validated to be used in the cGMP peptide synthesis. Now, later on, the customers provide us a lot of feedback to, for example, have a larger size of RVs or have a higher number of the RVs or more of the amino acid. So for this reason, we have come with a 500 milliliter, for example, reactor, or as you see in here, you have only 50 milliliter, or you have 100 milliliter, or you could have a 200 milliliter, and so different sizes, as big as a liter size reactors. Now, the amino acid container, there are 24 of them. And the reagent and solvent, you have 6. Now, these can be delivered to any position, from solvent reagent to AAs, or to reactors, or from the AA to another AAs, or from AAs to RVs. So it is very, very flexible. Now, the size of the AA can be a 90 milliliter, or it can be 250 milliliter, or it can be 500 milliliter. So they're the same thing with the measuring vessel. The measuring vessel, which is in here, is a 500 milliliter, where in here, now I have only a 20 milliliter on there. So you can exchange them, very simple to take off. For example, taking off this is very simple. You take off this and you put a larger size or a smaller size. So it's interchangeable and it's easy to simply exchange it. The system is very, very flexible. It's flexible not only for the chemistry, but also for the quantity of that you're going to synthesize. Focus XC has the most flexible and very easy to use. In the top of in here it says synthesis. That is where you write the name of the protocol and you start your synthesis. The setup is where you do a new synthesis and calibrations, etc. And administration is where you provide a password for the user. Log file is anything that you do with the system, automatically log it on the hard drive and to the millisecond. And the number of milliliter and what the step it was stopped, and when it stopped, what was the type of thing, failure, etc. And print, of course, is clear, and help is wherever you need help to understand the system. Now, if we go to the synthesis and if you're trying to either write a new synthesis or load a sequence which is you already has, or delete the synthesis. For example, in here you got 1, 2, 3 as ASP, ASQ, and ACP, and so on and so forth. So, but if you want to recall one of those, all you have to do, you press and you get the synthesis. For example, if you press this, here are the 3 or 4 protocol sequences written in here for all 4 RV, reaction vessel. So you can start, and all you have to do in here, press run, and if you press run, automatically comes in your protocols. So here is a protocol automatically written for the whole synthesis. And it's very, very simple. Very, very simple. If you read in here it said fill RV 1, 2, 3, 4 from DMF with 5 milliliters. So what it does, it delivers 5 milliliter DMF to the reaction number 1, reaction number 2, reaction number 3, and reaction number 4. Now, if you do need to have a different quantity, for example, reaction number 1, RV, 10 milliliter, the RV2, for example, 5 milliliter, RV3, 25 milliliter, you can do that, but those things you have to write it individually. So it's very simple, or empty RV 1, 2, 3, 4, all the RVs, all 4 reactors will be simultaneously empty or simultaneously would be washed. For example, wash RV 1, 1, 2, 3, 4 with a 10 milliliter DMF and mix for 10 seconds and empty to the waste 1, for example. Very simple. So now, if you are going to be rewriting a new program, a new sequence, for example, you go back to a sequence, to the synthesis, you say new synthesis, and the name, for example, assume we're going to write HS-123, for example, the name of the sequence. So I write this, we say okay, now it comes in here. All you do in here, pick and drop. For example, glycine, and the next one is a tyrosine, for example. The next one is alanine, for example, or a valine, for example. And then you're coming in, you continue this until the sequence is finished. It doesn't matter, it has to be 4 amino acid or 20 amino acid or 40 amino acid. You choose the right sequence. And then if you want to write RV2, the same thing. You just pick and drop. For example, the lysine, the next one is a leucine, the next one, for example, tyrosine, and the next one is aspartic acid, for example. Or you can put one more, for example, alanine. So this is 4 amino acid, this is 5 amino acid. So you can write the sequence continuously, write up the rest of them. Then you're coming in here and you simply write a protocol or provided. Now you come to here, you choose how many milligram resin do you have. So you choose the number of milligram, a number of fold, how many excess of the amino acid, for example, and here chosen 5-fold, and substitution of the resin is 0.5. So now it's just simply calculate how much material is going to be used. All you have to do, you do not really have to go anywhere in here because you set up this once and you use the same thing over and over and over. Or you can come in and make the changes. It's not important. Automatically use these number to adjust the rest. Then you say apply to all the sequences, and now you come in here and you choose save to save what we wrote, and now you simply start run the process. Very simple and very easy. Now you have a protocol for the reaction number 1 and 2. The first thing it's going to do is going to swell. So fill RV12 from DMF with 4 milliliters of solvent, which is DMF. And it mixes for the 15 minutes, and then it's emptying. And then go through a wash and continue to a deprotection using 20% piperidine and to the deprotection. And this continue for the coupling and washes exactly as you go through in here. Now I'll show you, if you take this one down all the way, for example, you see that you have the total of 263 step process. But the last one is the wash RV2 with 12 milliliter, because remember you had RV2 which was 5 amino acids. So no longer you have the RV1 because RV1 is finished already. And it does the deprotection and finally become to the end. And then when it's finished, the synthesis automatically, and a screen comes up and it shows you as follow. It comes to the end of synthesis, it gives you this. Your synthesis has completed, and it asks you a question if you like to, for the automatically the system to be cleaned up, clean the synthesizer, or skip the cleaning. So you can clean the synthesizer automatically, you wash it, you get ready for the next synthesis.